Hello everyone, in this video we are going to talk about the radius of nth shell or nth electron orbit, but before that let's just review what we know about Bohr's atomic model. So Bohr's atomic model says that there is a positively charged nucleus consisting of protons and neutrons, and there's an electron which revolves around the nucleus in circular orbits, and these circular orbits have fixed energy levels, or these um, energy levels are they have quantized energy levels, discrete energy levels, whatever you want to call it. Alright, so to know to calculate the expression for the nth electron orbit, the radius of nth electron orbit, we need to know about an important postulate. It says that the angular momentum of an electron in any orbit, in nth orbit, is given by, in any orbit, it is given by nh by 2 pi. So the angular momentum should be an integral multiple of h by 2 pi, and h is called Planck's constant. Planck's constant's approximate value is 6.63 into 10 to the power of minus 34 joule seconds. It's actually 6.625 into 10 to the power of minus 34. That is also the approximate value. And if you ask me where this comes from, it actually comes from this equation, E equals hf. We're going to study about this equation in detail and about quantum mechanics in our upcoming videos, but for now we need to know that h is a constant whose value is 6.625 into 10 to the power of minus 34 joule seconds, and its unit is joule seconds. Alright, so this is known as the angular momentum quantization postulate, which says that the angular momentum of an electron in any orbit should be an integral multiple of h by 2 pi. So if I ask you 3h by 2 pi, is there any orbital with angular momentum 3h by 2 pi? Yes, n equals 3, that's the orbit. Well, what about 2h by 6 pi? What about this? If you compare it with the general form, so if you equate 2h by 6 pi to nh by 2 pi, you're going to get n equals 2 by 3. So this is not possible, because remember what we said, the angular momentum should be an integral multiple, so n has to belong to integers, whereas here it isn't. So there is no such shell with such angular momentum. So this is known as angular momentum quantization condition. Alright, so this, and we need to discuss about one more important concept. Let's say there is a circular path and there is some object which is traveling this circular path, and it has a radius r, and let's say that its linear velocity is v, and r and v are mutually perpendicular. Well, the angular momentum of this object is just going to be, well, the general formula is given by r cross p, or rp sine theta. And remember, p equals mv, momentum equals mass into velocity, so I have mvr sine theta, and here theta takes the value of the angle between r and v, which is 90 degrees, so sine 90 is 1, so the angular momentum is just mvr, right? So similarly, in the case of an electron also, the angular momentum is going to be mvr. So we have another equation L, that is mvr. So mvr is equal to nh by 2 pi, and h by 2 pi can also be written as h bar. So we're gonna use h bar in a lot of videos. Instead of h by 2 pi, we're gonna use h bar. So mvr equals nh bar. So let's call this equation 1. Well, what is equation 2 going to be? Because we need something else to eliminate v so that we can find r in terms of n and some other constants. So mvr equals nh bar. And one more thing, very important, whenever you have an object which is performing some circular motion, be it uniform or non-uniform, anything, there is always going to be centripetal force required to do so. It is a radially inward force or a center seeking force which acts on an object in circular motion, on any object in circular motion. And its formula, it's given by mv square by r. So mv square by r is equal to centripetal force. And here comes the very interesting thing. Over here, the centripetal force, what's the centripetal force over here? We have a charged body, we have a negatively charged body, here we have a positively charged body. Well, if you've studied Coulomb's law really good, or if you haven't, don't worry, I'm discussing it right now. So if you have two charges q1 and q2, so charge is denoted by the letter q. So if you have two charges q1 and q2 separated by a distance r, then the electrostatic force between them is going to be k q1 q2 by r square. Just like how gravitational force between them is going to be g m1 m2 by r square. Well, why aren't we considering the gravitational force? That is because, the gravitational force is, let's see, electrostatic force is 10 to the power of 42 times the gravitational force. So this is the gravitational force is very negligible in this case, so we are not considering the gravitational force. So Fe equals k q1 q2 by r square, and k is given by 1 by 4 pi epsilon naught. Well, in case when the medium is free space, epsilon becomes epsilon naught. So this k depends on the medium. Well, if the medium is water, then it's going to change. The value of k is going to change, so the value of Fe is going to change. So k depends on the medium. So when the medium is free space or air, then epsilon becomes epsilon naught. I don't really remember the value of epsilon naught, and it's not needed right now. So k equals 1 over 4 pi epsilon naught. So Fe can be written as q1 q2 by 4 pi epsilon naught r square. So Fe equals q1 q2 by 4 pi epsilon naught r square. Now the really interesting question is, what's q1 and q2? Well, one it's nucleus and another it's electron. Well, we know that the charge on an electron is 1.6 into 10 to the power of minus 19 coulombs. So what is the charge on this nucleus going to be? Well, then let's say there are n number of electrons. So there are going to be, if there are n number of protons, there are going to be n number of electrons to keep the atoms stable. So if there are n number of electrons, then the nuclear charge is going to be n times the charge on one electron, right? And n here is just the atomic number, right? So the number of protons in an atom is determined by the atomic numbers, which is given by Z. So the nuclear charge is just going to be Ze. So Fe equals, let me just write over here, Fe equals Ze, that is the charge on the nucleus, times the charge on an electron, that is Ze square. It becomes Ze times E, Ze square upon 4 pi epsilon. Alright, so Ze square upon 4 pi epsilon naught r square. So this is the electrostatic force that is providing the centripetal force in this case. Now let me just erase all this. We have these two equations, mvr equals nh by 2 pi. The angular momentum is an integral multiple of Planck's constant by 2 pi, or h bar, nh bar. It's an integral multiple of h bar. So and mv square by r, the centripetal force, is being provided by the electrostatic force, which is given by Coulomb's law, that is kq1 q2 by r square. So that's just nothing but Ze square upon 4 pi epsilon naught r square. Now if I square on both sides, what do I get? M square v square r square is equal to n square h bar square. And I also know that mv square by r is equal to Ze square upon 4 pi epsilon naught r square. Now I can cancel one of the r's. Now if I divide both of these equations, let's see what we get. So let's see. So m square v square r square divided by mv square is going to give you mr square, and that's equal to n square h bar square 4 pi epsilon naught r, just taking the reciprocal, divided by Ze square. So can cancel out the r's, and the final expression, this is not the final expression, I guess we can simplify this further. So r equals n square, and h square can be written as h square by 4 pi square. So n square h square 4 pi epsilon naught divided by 4 pi square Ze square m. So 4 pi square Ze square m. So let's see what all we can cancel. So pi and pi, 4 and 4, and that's it. So that's it. So here we have the final expression. I'll just write it over here. Let me just erase this part so that I have more space. So you know what, just a second. So I'll erase this part. So r sub n, that is the radius of the nth shell, is thus given by n square h square epsilon naught, 4 is cancelled, upon pi m Ze square. And since we're talking about a hydrogen atom, Z is going to be 1. So I can neglect the Z over here, and I get n square h square epsilon naught by pi m e square. And notice that h is a constant, epsilon naught is a constant, pi is a constant, m is a constant because pi is a constant, mass of an electron is constant, charge on an electron is constant, permittivity of free space is constant, and Planck's constant, that's a constant. And I can also so since they are all constants, they'll have some value, and if I put the values in, let's see what I get. So r sub n is going to be equal to, well, h square epsilon naught upon pi m e square. Let me call that a naught, and I have n square. And what's this? What's the value of this a naught? It is 0.529, and we have n square. And what's the unit going to be? It's going to be angstroms, and you could always convert it into meters by multiplying it with 10 to the power of minus 10. So a naught is called the Bohr radius. So in the next video we are going to calculate the velocity of an electron of a shell, an electron in a shell, in the nth shell, just like how we did for the radius. And it's a pretty easy one because we already know r, and with the help of this r we can calculate v sub n very easily. And yeah, so we're gonna do that in the next videos. Till then stay tuned, and thank you all so much for watching. Bye.